Hi guys, welcome to Colossus Mathematics class. Don't forget to subscribe, like and share this video. In today's class, we want to talk about partial derivative. Now, what is a partial derivative? A partial derivative of a function of several variables. It's a derivative with respect to one of those variables with others held constant. So this partial derivative is something that you are familiar with. I get what I'm saying. So in this video, we are going to be bringing similarities between the differentiation we did before and this partial derivative. So they said partial derivative is used in vector calculus and also in differential geometry. And we can also note the notation for partial derivative. So we have for f of x, you are going to write it as, so when you write fx like this means the differentiation of your x, the differentiation of your function with respect to what x only. I get what I'm saying now. So that is just what all this thing means. I get what I'm saying now. And this is the formula. When you write fx means the f die x. I get what I'm saying. That is the partial differential of the function with respect to x. And this is the limit formula, all right? And if it is y, you have f of y to be what? That is the differential of y, that is die f die y, that is the partial derivative of x of f with respect to what? Y. And this is also the what? The formula. So the formula for this is fx plus h comma y minus fx of y all over what? H. And you can see this is the same thing, just like what's it called? Limit. Under limit, you note this formula. We use it when we're talking about limit. I get what I'm saying now. And the same thing goes for y. So for y, it is x comma y plus h all over h. I get what I'm saying now. So we go on to partial derivative rule. Partial derivative rules, just like the same thing we do in our differentiation. You know, under differentiation, we have the chain rule, the product rule, the quotient rule, the logarithmic rule, and so many other rules. The same thing applies to this. So we have different rules under partial derivative also, and that's what we are going to study today. All right. So talking about product rule, you know, in product rule, we say that if we have two functions, that is, if I have x comma y, that's in normal differentiation, you say if I have x comma y. But here now, we are dealing with respect to what? Function. So we said if u equals to f plus y, I mean f comma y, x comma y multiplying g of x comma y. I get what I'm saying. So what will now be the derivative? It is very simple. You know, for respect to x, you have die u die x. You know, normally if you have u equal to x, if you have u equal to, I mean, let's say you have y equal to uv. If you have y equal to uv, you are going to see the dy, you are going to say dy dx equal to what? V, you can use anyone, v du dx plus what? U dv dx. I get what I'm saying now. So with respect to this is our u, this is our what? V. I get what I'm saying. If we relate it with this is our u and this is our what? V. So you can see v du dx. I see now. You can see die f die x and what? F, which is your u. Can you see now? Then die g die x. That's with respect to x. And for respect to y, the only thing that just changed is this x and y. I see that now. That is the only thing that changes there. The same thing applies to quotient rule now. The same thing applies to quotient rule. You know, normally in quotient rule, if I have y equal to u over v, you are going to say your dy dx equal to what? So let us box this so it won't affect whatever we are doing. Don't forget to subscribe, like and share. So you know, this will just be what? If you are dealing with this, you are going to say this is v du dx minus u dv dx all over what? V square. Now let us relate it with this. You can see this is your, if you relate it with this is your u and this is your what? Your v. So you can see v, can you see du dx, can you see now, di v, di f, di x, are you seeing that now, minus u, which is your f here now, that's fx of y, then dg dx, then v square. You can see your v, which is g of xy all square. Are you seeing that now? The same thing goes for y. The only thing that just changed is what? With respect to y. Are you seeing that now? So that is how you are going to do anything that deals with partial differentiation. I get what I'm saying. So these are the rules. So the third rule now, the third rule that we have is called the chain rule. So when we talk about chain rule, I'm sure you are familiar with chain rule in differentiation. Are you seeing what I'm saying now? We are familiar with chain rule in differentiation. And under this, we are going to be relating it with partial derivative. I hope you are following. Don't forget to subscribe, like, and always share this video. So in this, we said if, look at this, if x equal to g of t, that is, if my x is a function with respect to what? T, and same thing as my y with respect to what? T, which is h of t. They said if they are differentiable functions, of t, and z equals to fx of what? Y, that is, z is now what? Is now a function of these two differentiation, of these two functions. Are you seeing that now? So what am I going to have? Very, very simple. Then I say that is, if I say z equal to f of x comma y, that is my z, if I replace my x here, that means my z will be what? F of g of t comma what? H of t. Alright, now, then what will now be my dz dt? This is what I want to get now. What will be my dz dt? Very, very simple. That will just be what? Dz dx, that is, you differentiate z with respect to x, multiplied by differentiating x with respect to t. Are you seeing that now? The first thing you are doing is differentiate z with respect to what? X, and you are differentiating x with respect to what? T, plus you are differentiating z with respect to what? T. I get what I'm saying. You are differentiating z with respect to y, and now you are differentiating y with respect to what? T. That is what we have here. Are you seeing that now? I go again. For you to do your dz dt, you are differentiating z. You can see that this is what I have. Are you seeing now? This is what I have. So the first thing you are doing is that you are differentiating z with respect to what? X, and you are differentiating x with respect to what? T, plus you are differentiating z with respect to y, and now you are differentiating y with respect to what? T. That is what all this means. Now, what if it is two independent variable? If it is two independent variable, that is what we go into next. Look at this. We said if x now is equal to g u of v, where your u is a differential and your v is also a differential. Are you seeing that now? So this is a different case now. Then they now say and y is equal to what? H of u and what? V are differentiable functions of the variables u and v. You can see that for this place, for the first one we did, it is just only with respect to one variable. But here now, it is with respect to what? Two variables. Now, how does that apply? Very, very simple. That will just be what? So if you want to have our z x of y, just like I did the other time, so this one now be what? F of what? G of u of v, comma, h of u, comma what? V. Now, look at this. I'm sure you remember how I will explain this. Now, look at this. Now, you want to now do dz with respect to what? U only. Dz with respect to what? U only. Now, what would that be? That would just be what? Differentiating what? Z with respect to x and differentiating x with respect to what? U. I get what I'm saying. You know, this is two variables, not one like we did here. I get what I'm saying. Not one like we did here. So this is two. So we differentiate z with respect to x, multiplying by differentiating x with respect to what? U, plus differentiating z with respect to y and differentiating y with respect to what? U, just like I did here. You know, this one is t. Now if it is for v, then you do with the same thing, just like now this u is now becoming what? V. I hope you are getting what I'm saying now. Now let us see example and see how this relates. So don't forget to subscribe, like, and always share this video. All right, so let's see example 1. They said determine the partial derivative of the following. We want to determine the partial derivative of the following function. And how are we going to do that? Very simple. Very what? Simple. Just follow me as we go together. Now, when they say find the partial derivative, here you have x and y. That means you are to do what? Die f die x, and you have to do die f die y. Are you seeing that now? So the first one now, solution. So for you to do your first function, which is f of x comma y, which is equal to 3x plus 4y. Now die f die x, what will it be? Now what do we say that f die x mean? Die f die x means differentiating this function only with respect to what? X. That is, it is only the one that have x that you want to differentiate. Now if you differentiate 3x, what will you get? 3. Is 4y, is it having x? No. That becomes what? 0. Simple. Are you seeing that now? Very simple. Now if you want to do the f die y, I'm sure you know what that means already, because I know you are smart. The f die y now means differentiating with respect to what? Y only. Is this having y? No. Is this having y? Yes. Differentiate 4y, what will you get? 4. I see that. You can see it's very simple, just like I said earlier. Now let's go to the second one. The second question. Second question says f of x comma y, which is equal to x square y plus sine x plus cos y. Now the first one, die f die x. How are we going to do die f die x? I'm sure you already know. That is what differentiating everything with respect to what? X only. If you differentiate x square y with respect to x only, don't forget x only, that means you are differentiating x square here. If you differentiate x square, what are you going to have? Differentiating x square will give you what? 2x. Are you seeing that now? Differentiating x square will give you what? 2x. So this is what? 2x. Then multiply by what? Y. Plus differentiate sine x, because it is having x. If you differentiate sine x, what are you going to have? You are going to have what? Cos x. Now cos y, is it having x? No. That means you leave it. Are you seeing that now? Then let's do the second one now, which is what? Die f die y. Die f die y will now give us what? Differentiate y only. If you differentiate y here, it will give you what? 1. 1 multiplied by x squared, that will give you what? X squared. Then is this having y? No. Is this having y? Yes. So differentiate with respect to y only, that will give us what? Minus sine y. Are you seeing that now? Because if you differentiate cos y, it will give you what? Minus sine y. So let's go to the last example for today before we wrap up. Now you can see that this is 3. This is f of x comma y comma z, which is equal to x cos z plus s square y cube exponential z. Now to do this third one, very simple, just like you have been doing. So the first one you want to do now is to do die f die x. You want to differentiate with respect to x. If you differentiate with respect to x, if you differentiate x, what will you get? 1 multiplied by cos z, that will give us what? Cos z, plus you are differentiating with respect to x. Don't forget, if you differentiate x square, what will you get? You get 2x. Abi, you leave everything as they are, so that's what? 2x y raised to power 3 exponential z. Are you seeing that now? So the second one, which is what? Let's do that here. That f that y. That means I want to differentiate with respect to what? Y now. Differentiating with respect to y, we means, is this having y? Is anything here having y? No. So since everything here is not having y, that means it has become what? 0. Now this place, are we having y there? Yes. If you differentiate y cube, what will you get? 3y squared. So that means I'm going to have 3y squared. Are you seeing that now? Then you write the others like that. So s squared exponential z. I get what I'm saying? I get what I'm saying. Now the last one now, you want to differentiate with respect to what? Z, which is what? That f that z. That f that z will now be what? Differentiating with respect to what? Z. If you differentiate with respect to z, that will be what? Differentiate cos z. Cos z will give you what? Minus sine z multiplied by x. So that will be minus x sine z. Are you seeing that now? Plus, if you differentiate exponential z, exponential z will still give you exponential z, because if you differentiate exponential x, it is still what? Exponential x. So the same thing as exponential z. If you differentiate exponential z, it will still give you what? Exponential z. So that means everything here still remains the same, which is x squared y cubed exponential z. So if you have any question concerning anything that we've done today, feel free to ask in the comment section. Feel free to ask in the comment section. I'll be there to answer all your questions. All your questions will be attended to. So don't forget to subscribe, like, and always share this video with your friends and loved ones. This is the first part of partial differentiation. By next class, I'll be uploading the second part, where we'll be talking about second derivative, third derivative, and higher derivative of partial differentiation. Thank you very much for watching, and do have a great day.